Hi everyone, we're about to learn how to apply these properties of different segments intersecting our circle. And they're going to create these angles, and if you watch the Prezi, you should have learned about at least one of those angle properties by now. So this first example involves angles created by a tangent line and a secant line. Okay, so who remembers what is a tangent line? Holy hot dog, you guys. A tangent line is a line or segment or ray that intersects the circle in exactly one spot, one point. So that's going to be the case, as well as a secant line, which, what is a secant line? A secant line does in fact intersect a circle and intersect it in two spots. So this circle's got a lot of tangent lines and secant lines in it. It's got several, which is pretty cool. The more secant and tangent lines, the better. All right, so let's refer back to that awesome property you guys already watched on the Prezi. So the property that's associated with angles created by a tangent line and a secant states that the measure of an angle formed by a tangent line and a secant is half the measure of its intercepted arc. Okay, so if we have an arc that is running through an angle created by a secant and a tangent line, if you take half the measure of that arc, bam, you'll get the angle. Or vice versa. To get the arc, if you already know the angle, you just double that bad boy to get the arc. Okay, so we're going to be using this property to help us find not one, but two different angles on the problem. Whoa, I'm already excited. Let's get going. Let me go back to the page. Come on. Okay, so we're going to be finding the measure of angle STU, which is this bad boy right here, and the measure of angle RST, which is this angle right there. So I'm going to put little question marks there so I know that's what I'm solving for. So I don't know this one yet. And I don't know this one yet. So that's angle STU and angle RST. Guys, I'm going to be solving for angle STU first down here in this lovely spot. I picked this spot out especially for this angle. It just deserves to be in that spot. Guys, and then eventually we're going to be solving for angle RST, but RST is a little involved. I've got to first find two different arcs before I can find that one. So I kind of just spread out my paper to organize it a little better because I like things to be nice and organized. All right, guys, let's get going. I'm already so excited. I can't even wait. Okay, so the measure of angle STU, okay, is this angle right here, which I'm going to highlight that bad boy so you guys can see it a little better. Let's see here. I think pink would be a good choice. All right, so the measure of angle STU. Okay, so this is an angle that is created by a secant as well as a tangent line. Okay, and so I need to spot the arc that runs through this angle, which is called the intercepted arc. Do you guys see an arc that runs through the angle that I highlighted right here? Do you see an arc that runs through it? Or an arc that starts and ends where the angle starts and ends on the circle? Oh man, I see it too, you guys. It is arc ST. So this angle's intercepted arc is arc S to the T right here. Guys, so this is the arc I'm going to be focusing on when I'm finding the measure of angle STU. So let's get going. Zoom it back out. Boop, boop, boop. Okay, so let's set this up. All right, so I'm trying to find the measure of STU. So the measure of angle STU equals, what do I do to its intercepted arc if I want to find the angle? You do, in fact, half it or divide it by 2. Okay, so this will equal 1/2 the measure of arc S to the U. All right, let's start solving. So the measure of angle STU equals 1/2 of the measure of arc SU, which, what is the measure of arc SU? Oh man, it is 166. So I'm going to fill that bad boy in right there. 166 degrees. Guys, and then pretty much we're almost done with this problem. So I'm going to multiply 166 by 1/2 or divide it by 2, because guess what? That is the same thing. So what is half of 166, or 166 divided by 2? Well, let's see here. So half of 16 is 8. And half of 6 is 3. So this bad boy is going to be 83 degrees. And guess what, you guys? Bam! That one's already done, so. Oh, man. I don't want to go too quick, though, because that means the problem will end. And the longer the problem, the more exciting, right? I know. I mean, we agree like we normally do. All right, so let's keep going. So now I want to find the measure of angle RST. Okay, but usually when we do this, we need an intercepted arc. Okay, what type of angle is angle RST? We've talked about this nifty angle. It's an angle whose vertex is on the circle. What angle have we talked about that has its nifty vertex point on the circle? It is an inscribed angle. Okay, so an inscribed angle has a relationship with its intercepted arc, which in this case is RT. But you're probably like, Miss Long, what do? We don't have a measure for RT, so how can we even find this angle? I'm so confused. Well, guess what, you guys? We're going to use other arcs in the circle to help us get there. Guys, if I know what these two arcs are, so arc RS and arc SU, I can find RT because what do all the degrees of a circle add up to equal? In fact, it is 360 degrees. You guys are on a roll today, on a roll. Guys, so if I know these two arcs, if I subtract those bad boys from 360, I'll get arc RT, which once I know arc RT, I will know angle R to the S to the T, okay? But again, you're probably like, Miss Long, we still don't know what one of our arcs is. I don't even know what arc RS is. Well, do you see an angle in the circle that might help us find arc SR using the property we just talked about a secant line and tangent intersecting a circle? Well, I have an angle created by a tangent line and a secant line. So if I have an intercepted arc, guess what? There's a relationship that we just talked about. What is the intercepted arc that is created by angle QRS? Heavenly hamburger. It is arc R to the S. So right here, bam. Guys, so this angle QRS, whoa, just did a really bad highlighting that. Sorry, guys. Okay, this angle opens up to that arc. So that is its intercepted arc. Guys, so we need to figure out what that arc is using this angle. Let's get going. Okay. I'm so excited. Okay. Come on, document camera. Can we cooperate for once? Gee willikers. All right. Here we go. Okay, guys, so first I'm going to find the measure of arc RS, which will help me find the measure of arc RT, which will then help me find the angle of RST. So let's get going. Oh, man. Okay, let's go. I'm so excited. Okay, so the measure of RS, arc RS, equals, okay, so if I know the angle that is created by the intercepted arc, what do I do to this angle to get its intercepted arc? Yes, you are correct. We do double that bad boy. So I'm going to multiply angle QRS by 2 to get the measure of the arc. So 2 times the measure of angle QRS. All right, let's fill in these bad boys and solve for the arc. So the measure of arc RS equals 2 times the measure of Q to the R to the S, which the measure of that angle is 71 degrees. All right, let's solve for this bad boy. So the measure of arc R to the S equals 2 times 71, which is 142 degrees. Guys, so this is going to help me to find arc RT, which will then help me find this other angle that we're actually trying to find, because that's what the original problem asked us. So we're getting there, you guys. Don't you worry. It's like a journey. We have to go through this journey together to get to angle RST. All right, so let's keep going. So I know now that this angle, I guess I'll fill in the values that we already know. That might be helpful, Miss Long. Geez, I'm always telling you guys to mark your picture, and I didn't even do it. What's wrong with me? Guys, so the measure of angle ST that we already found is 83 degrees. And, sorry, that's 83, that's struggling a little bit. Sorry, guys. And the measure of arc RS is 142 degrees. So I'm going to label that my picture now. Okay, so I know two of the arcs, and I know all three of these arcs will have to be 360. So let's get going on that bad boy. Oh, man. Sorry, guys, I'm closing all these caps so my markers don't dry out. Okay, so the measure of arc RS plus the measure of arc ST plus the measure of arc RT should all have to be 360. All right, let's see if we can do this and solve this bad boy for R to the T. All right, guys, I'm going to fill in the values that I just put in my nifty equation. So RS, let's fill in these values right here. Okay, so RS is, let's see here. Okay, R to the S is 142 degrees plus S to the T, which is 166 degrees. Plus the measure of RT, which I don't know yet, so I'm just going to write the measure of arc RT, equals 360. So that bad boy didn't change. All right, guys, let's solve this thing for arc R to the T. All right, I'm going to combine my like terms, which are these two right here. So let's see here, 142 plus 166, that's going to give me 308. Yes, 308 degrees. Plus the measure of arc RT will have to be 360. Oh man, we're so close. I can smell the finish line. Let's get going. All right, so how do I bring 308 to the other side? Yes, my intelligent students, you do subtract 308 from both sides. Which 308 minus 308 will cancel. Sorry, my marker's drying out. Cancel and turn to 0. And 360 minus 308, well, 360 minus 300 is 60, and then 60 minus 8 more will give me 52 degrees. Oh man, so guess what, you guys? The measure of arc R to the T is 52 degrees. Bam, we're getting closer, we're getting closer. All right, and I'm going to label my picture with the 52 to help me visualize what's going on. Okay, you guys, I'm so close. So now I want to find the measure of angle R to the S to the T, which we already talked about. That was a special angle, an inscribed angle. And inscribed angles have a special relationship to their intercepted arc. So I'm going to label the inscribed angle and its intercepted arc. Guys, so this is the angle we're trying to ultimately find. I'm going to kind of have to squeeze it in there because the pink and blue highlighter markers are fighting it right now. Okay, so that angle, RST, technically it goes down here, but as you can see now, my picture looks like a hot mess. But anyway, so RST opens up to arc RT. RT is the intercepted arc of angle RST. Sorry, my picture looks really bad right now. Sorry, guys. So if we know the intercepted arc of an inscribed angle, what do we do to the intercepted arc to get to my inscribed angle? Yes, correcto mundo. You would divide that bad boy by 2. So guess what, you guys? We're so close. Let's get this thing done with. Even though I don't want to, because that's sad. I don't like ending problems. It depresses me, but it's okay because guess what? Another problem's about to happen, so I'll get over it shortly. Okay, so the measure of angle R to the S to the T equals 1/2 the measure of its intercepted arc, which is arc RT. Sorry, guys, I'm trying to squeeze this in because I'm running out of space. I'm going to zoom in so you guys can see that better. Okay, so I know that's really sloppy because I was trying to squeeze it into the side and epically failed, so I'm sorry. Guys, so that says the measure of arc RT. So on your paper, make it look better than what I did on my paper. Okay, so the measure of angle R to the S to the T equals 1/2 of that arc, which arc RT is 52 degrees. So I'm going to fill in that bad boy right now. Bam, so 52 degrees. Alrighty, and half of 52 degrees is going to give me 26. Oh man, so the measure of angle RST equals 26 degrees. And guess what, you guys? This problem is officially Dunzo. Look at that. That was pretty epic, you guys. Way to start off this section, right, with this hugely epic problem. Look at that. All right, so now that we learned how to solve with angles created by a tangent line and secant lines, we're now going to learn how to create or how to solve with angles created by two chords or two secants intersecting inside the circle. So these are going to have some different properties, so get super pumped up. All right, guys, thanks for having fun with me on example 1.